The electromagnetic spectrum covers a very wide variety of electromagnetic waves, including X-rays, visible light, microwaves, and radio waves. All of these are the same form of wave, just at different frequencies. Now, some of these frequencies have items in nature that naturally produce these frequencies, and others are used on a commercial level, especially for communication in the form of mobile phones and radio stations. However, in some countries, there now may be a problem with some of these frequencies. So what is the issue, and how can it possibly be solved? Well, in some countries like America, where there are a huge number of commercial radio stations that use all the various generations of mobile or cell phones, this means that the number of frequencies used by this traffic is beginning to become an issue. In order to get a clear signal in each area, the specific broadcast for a radio station or a range of mobile phones is given a set part of the frequency. Without this regulation, the signals would all clash, and all that we heard was just static. In addition, only certain parts of the electromagnetic spectrum are suitable for each purpose, so the regulators have to allocate or sell specific parts of the spectrum for each use. It's getting a little crowded. So with the new 5G phones being rolled out, these devices need new frequencies to be allocated to carry the huge amount of data which are expected to need. Existing overcrowded frequencies means that some authorities might be using parts of the spectrum not used before, including one part of the spectrum at 24 gigahertz or 24 billion cycles per second. It has recently been auctioned off by the Federal Communications Commission. And whilst this frequency isn't being used by any current company, it's very close to that being transmitted by water vapour at 23.8 gigahertz. It's this particular frequency that enables weather satellites to measure where the water vapour is and how much of it is present in the various parts of the atmosphere. This measurement of water vapour by satellites is one of the key factors in how weather forecasts have improved over recent years. However, the signals transmitted by water vapour are not that strong and could easily be lost or masked if there are other transmissions on the same frequency. Now, if all of the 5G devices are perfectly calibrated and broadcast only at 24 gigahertz, there's enough of a gap between frequencies to prevent interference between mobile phones and the weather satellite detection systems. However, these devices have a history of not sticking precisely to a narrow bandwidth, instead overlapping with nearby frequencies. In addition to the issue with 24 GHz, there are other frequencies which are also being considered for auction that again may interfere with the other weather monitoring frequencies. Now, it might appear that the gain from the new 5G might be worth losing a little in the accuracy of weather forecasts. However, one of the key uses for tracking of water vapour is in predicting the path of hurricanes. Lack of accurate water vapour tracking could mean there's a loss of between 1 and 2 days of forecasting about the strength and path of a particular hurricane may be following, and that loss of advanced warning could result in a significant loss of life. In addition to hurricane tracking, monitoring of the weather is an international operation with the various weather bureaus all sharing the information to construct a global weather forecast. This is important since a developing weather pattern thousands of miles away can have a direct impact on the local weather. This loss or reduction in quality of one region's data on the weather will impact the weather quality forecasting internationally. So if the clash of frequencies is a problem, what are the possible solutions? The most obvious one is to ensure that all the devices and equipment meet rigorous standards so they don't overlap with the neighbouring frequencies. Next, there needs to be a recycling of old or underused frequencies. The use of a particular frequency could be time limited or subject to periodic renewal. There's some frequencies which have only been used by a handful of early generation devices or by small broadcasters. These could be switched off and the frequencies could be reused for higher traffic purposes. This could be awkward for those few people still using it for the old function.